In this episode of A-Series Rockets, we're stepping it up a notch. We're talking some real high-pressure topics, and you can take it literally. But first, let's rewind. In episode 7, we built our first 3D printed part, FS1. Since then, we've moved ahead and made FS2, all the way up until FS5. All feature a similar but yet very simple design. Today, that's going to change. FS6 will feature some more bells and whistles. Let's take a look. As with the previous episodes, we'll split it up into parts, so you can go to the part you're interested in the most. Part 1. One-way air seal. Design. Part 2. FS6. Design. Part 3. Conceptualizing the ground support equipment. As you can see, this episode does not involve any printing or testing of parts, and that's for a good reason. I try to keep my videos short so they're easier to watch. The printing and testing will be done over the next few episodes. I started the designing process for the one-way air seal by taking a look at how others have done it. I personally thought about the design using some form of ball that gets pushed away by the pressure, and it turns out that's one way to do it, but there are plenty of other ways you can achieve your goals. I found out the official term for a valve like that is a check valve, and that the simplest, most used design are actually based on gravity, and not as much on pressure. The more you know. I then started looking on Thingiverse for check valve designs that may be on there, and I found this one design by Mirko Engineer? Sorry if I butchered your name, mate. It looks kinda simple, and I tried printing it to see how it works. As you can see on the photo I took, the printing isn't ideal. It has a lot of issues, especially with overhangs, so I tried fixing that. Next time-lapse you will see, it's actually already on your screen, will involve me designing a new check valve based on what I've seen that should be printable in 2 parts without any overhangs. Let's take a look. I started working on FS6 based on the design I had of FS5. I remade it in a bit of a higher quality, as you can see here. I now removed FS5 and started working on FS6. And I applied the same mechanics I did to FS5 to get the same base plate but in a bit of a higher quality. Then I took this built-in bolt from Blender and I started stripping it down because we only need the screwing mechanism. And after that was done, I inserted the screwing mechanism into the figure itself, into FS6, and I started working around it to see how can I integrate it. This is not a final item that will be added, but it will be a test print so we can see how it can turn out, how it looks, how it works, so we can adjust for later prototypes. I then spent a lot of time fixing the vertices and the faces on the model, as you can see there, because there probably will be a way to automate it, but I haven't found it yet, so it took a lot of time. Then I had to start working on connecting FS6 with the screw itself, with the screwing mechanism. I struggled finding that out, as you can see here. I tried a lot of different things, but at the end it didn't work out. So what I started doing was just extruding the ends of FS6, putting it at the same level as a screw, fixing some faces here and there, and then I started connecting things up, just checking out how it works. And after it was finished, we basically end up with something that would become FS6. So that's that. Back to the video. We are back to the animation board, and this is the A1. I don't want to come near the thing once it starts filling up, because it'll basically be a tiny bomb given the amount of pressure that's on it. That's why we need GSE, or ground support equipment. These are tools we can use so we don't have to come close to the rocket anymore once it starts fueling. GSE is usually used for fueling the rocket and starting the engines. We will use a similar system. The A1 will make use of air pressure as its propulsion method. This is a very weak form of propulsion, but it's my very first time doing this, and you have to start somewhere. The air itself will be supplied by a bike pump. The reason why I take a bike pump instead of an air compressor is because of the size of the rocket. Using an air compressor will be totally overkill, and with a bike pump, I'll be able to control the flow rate of the air going into the rocket a tiny bit better. Now, to connect the bike pump with the rocket itself, we need to use some tubing. This is also where the check valve will come in. The valve will connect the tubing with the rocket itself and prevent air from escaping the rocket once loaded. The other hole, made in FS6, will be for a pressure gauge. We can connect onto the rocket, and with the check valve unlocked, so the gauge will be able to access the air within the rocket. That way we can check how much air is loaded. Now, GSE also needs a way to retreat from the rocket before launch, otherwise chances are it'll get destroyed by it. Since our objectives are simple, we can just use some string to get it away from the rocket. When all that is finished, we have a rocket ready to launch with all GSE removed. All that's left is counting down and letting it go loose. This was quite a technical episode, I know. I hope you enjoyed it nonetheless. I really enjoyed making it, and I hope to see you all in the next episode, where we will print these parts and see if the concept will actually work out. See you all then. Bye bye.